In this video, I show you how the antechamber of the Great Pyramid may have worked as a mechanical flow regulator using rope, rollers and moving blocking stones to control water on its way to the king's chamber. Hi, my name is Tommy and I'm an independent researcher based in Sweden. I have no formal background in Egyptology, but my fascination with the Great Pyramid started over 20 years ago. Over those years, I have approached the pyramid the way an engineer would, since it's most likely a building that operated than rather just stood. The question I kept asking was not what it symbolizes, but more of how parts of it could actually work. In my work, I use 3D modeling and 3D printing to test ideas physically, not just on screen, but as real working models you can hold in your hand and operate. I believe that if a mechanism truly worked in ancient times, you can demonstrate it today at a scale. Of all its spaces, the one that held my biggest interest was the antechamber. I first proposed a rope and roller mechanism back in August 2023. Now I'm back with a new, larger version and more to show. Thanks for visiting and let's get to it. The triangular damage, a mark above the king's chamber doorway that points to something that happened here, long after the mechanism went silent. Blocks in the antechamber. Granite blocks found scattered outside the original positions that I believe belong to this very system. The roller system, my idea. 3 rollers sitting in the wall's guide grooves, doing work no one proposed before. The rope system. The rope path that ties everything together and drives the whole mechanism. The floor pockets. Small recessed pits in the floor, not random, not decorative. I have a theory for what they were built to catch. Buoyancy and the valve cycle. How rising and falling water triggers the whole thing automatically. Water and the sarcophagus, where all of this water were headed and what filled up because of it. By the end, I think you see the antechamber differently. The taper in these grooves isn't a small detail. It's essential to how the entire mechanism worked. It's what kept the top of the passage sealed, so no water could spill over into the king's chamber. What you see on the south wall today isn't what was there initially. It's been restored, and in that restoration, this critical detail was lost. Petrie documented these grooves back in 1883, before modern restoration ever touched them. William Matthew Flinders Petrie is considered the father of modern Egyptology. He was the first to survey the Great Pyramid with real scientific precision, measuring it stone by stone, passage by passage. His findings were published in the Pyramids and Temples of Giza, still the most detailed physical record of the pyramid's interior that exists. And he was explicit about the taper. Here's what he wrote in section 49 of his 1883 survey.
The south wall has 4 vertical grooves all up it, which have been hitherto supposed to have extended down to the top of the passage to the king's chamber. This was not the case, however, for, though much broken away, it is still clear that they became shallower as they neared the bottom, and probably ended leaving an unbroken flat surface over the doorway.
And that's exactly what today's restored grooves don't tell you. Look at the wall now, and the grooves run straight and uniform top to bottom. No taper. No sign that this seal ever existed. Here's my humble explanation on its importance. In my reconstruction, this taper sits at the bottom part of the grooves, just above the doorway, sealing it. The blocking stone itself, moving in its own separate groove within the antechamber, was what actually opened and closed the passage. One thing I need to correct here myself, in my 3D model I also built these grooves as rectangular, flat-sided, straight corners. But Petrie's documentation and the photographs show something different. The original grooves were rounded. That's a detail my model gets wrong. And it's worth being upfront about it, because getting the cross-section right matters for understanding how this system actually sealed. Now look up just above the doorway. This is how it looks today. There is a triangular scar in the granite. This was documented by an independent Japanese researcher who went by Joss, who photographed and studied the antechamber's south wall in detail and published his findings on his own website starting in 2002. That site is still viewable today through the Internet Archive. Joss noted plainly that this damaged portion has since been restored, and he described the damage itself. Something harder than granite struck this spot in the past. So when you compare the wall today to Petrie's 1883 record, you're not just looking at wear and repair. You're looking at the loss of a feature that was permanent, essential, and central to the whole sealing system. Scattered granite blocks turn up in more than one place today. Of the 4 that are known, 3 sits in the lower passages of the pyramid, and the 4th now sits outside the entrance, though none of them are necessarily where they were first discovered. They've been moved since, and the present locations shouldn't be mistaken for the original find spots. That block now sitting outside the entrance carries 2 complete holes, plus the remainder of a 3rd. But look closer, and several of them share something specific: drilled holes, cut at positions that match the spacing of the 4 grooves in the antechamber's south wall. That's not a coincidence you can wave away. If these blocks were just discarded stone, there's no reason for the holes to line up with features as precise as the south wall grooves. The match tells you these blocks were made to work with that wall, to be raised and lowered through it, using rope threaded through those very holes. This is my interpretation of how they fit, not a confirmed identification, but it spills directly from the physical feature of the stone themselves. So the question becomes, which of them and where do I place each one? In my reconstruction, I start with the block I placed to the south, the red block in my drawings. Its holes and proportions, as I read them, match up as the housing for the system, the point where the rope anchors and the mechanism takes its seat. This block has distinctive feature, a triangular top. Why it was cut that way I can only guess. But that shape is what first pointed me toward the damage above the King's Chamber doorway. Damage that Joss, a Japanese researcher, had already identified as caused by something harder than granite. A wedge-shaped top striking granite leaves exactly that kind of mark. That damage wasn't caused by the mechanism operating normally. It built up over a long period of time, most likely after the system had already fallen out of use. Once I connected my own observation with Joss, the red block stopped being just a loose piece of stone in my mind and became the match for the damage that had gone unexplained for so long. With the red block fixed in place, its holes sit at what I calculate to be the right height for the rope to pass through freely and continue up into the grooves above. The two remaining blocks take their positions relative to it, each one's holes and dimensions supporting where I put them in sequence. For the other two, I simply modeled them as rectangular. I want to show you how this idea actually took shape. Not in my head first, but in CAD, one ruler at a time. I started with a single ruler, placed at the south position, sized so its diameter sat flush against the south wall's groove, no gap, filling the curve exactly. But looking closely at the wall, I found something that changed the shape of that ruler immediately. The west side steps down further than the east side. Two different heights, not one. A single uniform diameter would never sit correctly on both sides at once. So the ruler itself had to be stepped to match. One diameter for the west step, a different diameter for the east. I also cut a series of ridges into the ruler itself, spaced to match the rungs of the grooves in the south wall. My first attempt after that was simple. Copy that simple ruler 2 more times, evenly spaced, and call it done. But when I laid all 3 out, the spacing that came out using identical diameters didn't look right to me. The gaps between the rulers left them without enough to hold against, nothing keeping them firmly in place across the row. The middle ruler turned out to need something different from the other two. The reason is simple. It needed a wider diameter than the outer rulers just to fill the space completely and leave no gap between ruler and wall. That solved the fit. The next question was what the rulers themselves were made of. My best guess is hardwood. The load on a roller isn't the full weight of a block. It's rope tension wrapping around a curved surface, similar to a pulley, sized large enough, tens of centimeters across. The way I modeled them, a hardwood roller has more than enough surface and strength to carry that load without crushing or splitting. It's not a stretch mechanically. With the rollers seated, the next question was what would actually pull the blocks, and that's where I turned to next. With the rollers seated, the next problem was what would actually pull the blocks. I say rope for simplicity, though it could just as easily have been some other cordage. I went through a fair amount of trial and error before landing on what worked. What I found is that it comes down to one continuous line. Up for the grooves, over the rollers and down to the portcullis slabs. One single line rather than separate ones for separate blocks. Once I tested it as one continuous line rather than several, the whole system moved together the way it needed to. If we do a section analysis, we see here how the rope passes through. Here I will show you how the blocks could sync automatically if they were out of sync. Now they are in sync, the red going down, the other two going up. Easy. But if it would, for some reason, be like this, they're off. What happens is, if I drive them up or down and I continue a bit up, continue, they end up being level. The green and yellow are leveled. And we do it the other way. If I force it to be off like this, and I lower up and down, eventually they will end up balanced and equal. And then if we add the side, it would look like this. And these would have very little room to jiggle. The last one can move a bit, but this one, all are going to be pressed down with the ropes. We can look here and we can see how it's completely closed. With this. Okay. Now here's something I want to be straight with you about. The floor pockets I've shown you in this reconstruction, I built them into the model, but I didn't invent them. When I went looking for information, I found something interesting on a website called Great Pyramid Explanation. An independent researcher, someone who spent years photographing this chamber and building his own scale models, documented the same feature. 3 pairs of pits cut into the floor, right at the base of the guide grooves on both sides of the passage. He estimated them at around 10 centimeters deep. In my model, I got them closer to 3. I can't resolve that gap from photographs alone, so take the depth as approximate on both our parts. There's older evidence too. John and Morton Edgar, surveying this chamber over a century ago, documented something related. These guide grooves actually sink a few inches below the finished floor level. That's not my proof of my pocket specifically, but it tells you this floor was never one clean, continuous surface. Even Edgar noticed that a century ago. Here's where I'll be honest with you, I'm not entirely sure why all three positions have one. In the operating system I'm proposing, only the southernmost stone actually reach the floor. So for that one, the explanation is simple. If this system used water, and I've already shown you why I think it did, grit and sediment would collect right where that stone needs to seat flush. A pocket there gives debris somewhere to go instead of jamming the seal. But the other two never fully descend in this finished system, so why cut a pocket there too? One possibility, before the rope was ever threaded through the system, all three blocks may have simply rested on the floor. Installed first, sitting at the bottom of the grooves, before the rope, the rollers, any of it, were put into place. If that's true, all three positions would have needed the same floor seating treatment at that stage, even though only one of them stays down there once the system is live. It's also possible it's simpler than that. Consistency during construction. The same tool, the same pass, cut the same way at all three positions. I don't have a confident answer, but that pre-installation resting position is the one that makes the most mechanical sense to me. Either way, it's good to know I'm not the only one who spotted it. Before I explain how this works, I want to be upfront about where the idea came from. The core notion that water and buoyancy might drive the antechamber mechanism isn't mine originally. Edward Kunkel proposed it decades ago, and Christopher Jordan, who passed away in 2014, built on that idea with his own buoyancy-driven theory. His site and blog are still online and worth a look if you want the original source. Antechamber flood cycle. Dry. Red block seated, sealed, chamber empty. Water entering, thin layer at the base. Water rising, red block partially submerged, slabs still most dry above the waterline. Red block fully submerged. This is the trigger moment, and the chamber is not fully flooded yet. Waterline sits below the top of the slabs. Block lifting, passage opening. Triggered right at the submersion point. Opened, held. Water can still be rising or steady. Doesn't matter, passage stays open. Water residing, red blocks starting to re-emerge. red block reseated, sealed, passage closed again, ready for next cycle. Here's something I want to flag. The water reaching the antechamber might not have arrived smooth and steady. If there was a pump action happening further down in the pyramid's water system, that could have sent pressure pulses traveling upward, and those pulses could have moved two ways. Through the water itself as surges rather than a gradual rise, or through the structure as vibration carried through the stone. Either way, those pulses could have helped the cycling of the blocks, giving the mechanism a nudge at the right moment. I want to be upfront. This part is inference, not measurement. It's consistent with the broader water system idea, but I haven't proven it. So the valve has cycled, the red block risen, the passage is open. Where does the water actually go from there? Straight through. The passage beyond the antechamber leads directly into the king's chamber. Once the red block clears the way, there is nothing left to stop the flow. Water moves from the grand gallery through the antechamber and into the king's chamber itself. And sitting in that chamber is the sarcophagus. Water rises in the chamber, the sarcophagus fills. But filling a sealed chamber with water raises another problem. Where does the air go? The king chamber has two narrow shafts, both running out to the surface. As water rises inside the chamber, the air has to go somewhere, and these shafts give it a way out. Without them, rising water would compress the air ahead of it, and the fill would stall. With them, the whole chamber can flood smoothly, air escaping upward as water comes in from below. And when the chamber eventually drains, the sarcophagus doesn't, not fully. The same cutout that let the water in also let it back out, but only down to the height of the notch. Below that line, the sarcophagus is sealed on every other side, so water under that height stays. The coffer is left roughly half full, holding its own water level, independent on whatever happening in the room around it. Before I close this out, I want to be straight with you what I don't know. Everything I've shown you rests on a few solid pillars. The 4 grooves, the granite and limestone blocks, the weight ratio, the physical model that proves that motion works. Those aren't in question for me. But the moment I move from this mechanism functions to this is exactly how it looked and worked, I'm interpreting. And you deserve to know where those lines are. So here's where I stand. Why is the red block's top cut triangularly? I've told you it points to the damage above the king chamber doorway, and I still think that's right. But why the builders chose that shape? Deliberate design, structural necessity, adjusting for the block's weight, or something else, I can only guess. There is a second possibility too. The 4 holes could follow the angled edges of the block's peak rather than sitting in a straight line. That could simply be how the rope needed to run. How big exactly are the other two blocks? My weight ratio, the number I've leaned on hardest in this whole video, is based on estimated dimensions and layout for two of the three blocks, not measured ones. If those estimates are off, the ratio shifts. I've been upfront about that throughout, and I stay upfront about it here. Then there's the motion itself, whether the blocking stones moved as easily as my model suggests, or whether real stone-on-stone friction at this scale would have demanded more than I have counted for. I can't say for certain. In my physical model, the roller don't actually roll. They behave more like fixed guides than true rulers. And I don't yet have a firm answer for why, or whether that's a flaw in my build or something closer to how they really worked. What was the rope actually made of, and how did it run? I've been saying rope throughout this whole video, and that's a simplification. Something threaded through those blocks and rollers, under real load for real cycles. Plant fiber, leather, something else, I don't know. And there's a harder problem sitting underneath that one. No wood and no cordage of any kind has ever been found in the antechamber or the passages around it. Nothing survives to confirm the material or even to confirm rope was the mechanism at all. I'm reconstructing that part from mechanical necessity, not from a found object. What I can say is that the rope splits into two lines over the middle roller, and on my model those two lines run unified over that roller rather than independently. The two ropes end up helping each other because of it. And on the portcullis slabs, I haven't ruled out that they could also come to rest at the bottom of the travel, not just the top, which would change how I read the cycle. There are a few more physical details I haven't resolved. I still don't have a settled answer for what the recessed floor pockets beneath the blocking stones were really for. On the south wall there are 4 grooves in total, guiding the rope and rollers, and those two were most likely tapered so that the seal would hold. Separately from that, on the west side of the antechamber, the rollers themselves sit in 3 half-circular grooves. And here's a detail I want to flag. As far as I can tell, those half-circular grooves were never perfect half-circles. Whether that's a construction limitation, wear over time, or something deliberate in the shape, I can't say. And whether the coffer in the king's chamber shows any signs of modification consistent with holding the water is something I haven't been able to confirm either way. Did a hydraulic ram pump assist the cycle? Somewhere lower in the system, water hammer could have given the stones an extra push right when the buoyancy tipped the balance. That's the idea, at least. What would have actually controlled a pump like that? Assuming one existed, I honestly don't know. I've turned over more than one theory here, and none of them has convinced me yet, so I'll say it plainly, the whole piece is speculation. Nothing measured. Nothing I can put a number on. And tied to that, whether the water rose in pulses, some kind of rhythm from below, rather than the smooth fill, is another question I'm leaving open. What were the seal actually protecting? I've talked about sealing the passage against water, but there's the real question of whether that seal was serving some other action happening in the king's chamber itself, something beyond just holding water back. One thought I kept coming back to, acoustic effects, even something like sonoluminance, could be part of why a seal was needed there at all. Not just to hold water in, but to contain whatever that action produced. I don't have a second explanation to offer with any confidence, only the sense that I might be missing part of the picture. Could copper handles in the queen chamber shaft have sensed the water level? This one's a bigger claim than most of what's on the list, so I want to be careful with it. The two shafts running from the queen's chamber don't reach the outside of the pyramid, unlike the king's chamber shaft. They stop short, sealed within the masonry. Inside these shafts are copper handles, a detail I first came across in Christopher Dunn's work, though I'm not adopting his broader theory here, just noting the object itself. What those handles were for has never been fully agreed on. One possibility I can't rule out, they could have been a way to sense from within the shaft when the water inside the pyramid had risen high enough. Something closer to a gorge than a fitting with no function. I don't have evidence that it pins it down. It's a possibility the mechanism opens up, nothing more. So where does that leave this? It leaves it as a hypothesis, a strong one, I think, built on grooves that are really there, blocks that really exist, a weight ratio I've calculated as carefully I can, and a physical model that proves the way it say it moves. But it's one hypothesis, not a settled answer. I could be wrong about the rope, I could be wrong about the pump, I could be wrong about the seals, or the floor pockets, or the coffer, and still be right about the core of it. I'm not asking you to accept this as facts. I'm asking you to look at the evidence, the grooves, the blocks, the damage, the ratio, the model, and decide for yourself whether it holds together. That's really all any of us can do with the building this old. Test the idea. See if it survives contact with the evidence. And if it doesn't hold up, let's go and try again. So this is just where I landed so far. Thank you again.